Assalamu alaikum students. Today we will discuss the estimation of population parameter, which is mean. We are going to discuss today two types of estimation. Number one, point estimation, and number two, interval estimation. Starting from the point estimation, point estimation, point estimation, the static value, which is computed from the sample information, which is used to estimate the population parameter, any parameter like variance, mean, but we are interested in mean. Following example shows how to compute mean by using point estimation method. Example number one, a random sample of amount paid in dollars for taxi fare from downtown to airport was obtained. Students, these are the data points. From the data, n is equals to 15, the number of observations, and if each point is represented by x, then sum of x is 271. Then the point estimation of mean is, we are going to find the point estimation from this formula, which is a very popular formula used for find mean. Now we just have to divide 271 by 15. For this, 271 divided by 271 divided by 15, what we will obtain is equals to 18.06. So 18.06 is the point estimation obtained from this example. This is the answer, students. A is the answer. Now example number two. Before going for other examples, I want to explain the interval estimation, which is the second type we have to discuss. Type 2, interval estimation of mean, is also called the confidence interval, which is a range of values constructed from sample data so that the population parameter is likely to occur within that range. That range means an interval where a lower limit and upper limit at a specific probability. The specific the specified probability is called the level of confidence. Commonly used confidence levels are and the corresponding Z score values are given in this table. Student, the first column shows the confidence level, which is a probability over which the confidence interval we will find. 90% means 0.90 probability, and the corresponding Z score is 1.65. Another example, which is 95%, which means 0.95 probability, and the corresponding Z square is 1.96. Students, I will make a separate video for which I will explain how to calculate on a specific confidence level the value of Z score. The following examples show how to estimate the population mean mu by using interval method. Example number 2, case 1a, when standard deviation of a population is known. An electrical firm manufactures TV picture tubes that have a length of life that is approximately normally distributed with a standard deviation of 40 hours. Students, we have given a population standard deviation, which is 40 hours. If a random sample of 30 tubes, this means the sample that contain 30 observations has an average life of 780 hours. This is the point estimated value, 780 hours, that constructed from the sample of 30 observation. We have to find 95% confidence interval for the population mean of all such tubes produced by this firm. Student, from the example, I have constructed the data N is the sample observations, which are 30. X bar represents the sample average or sample mean or point estimated value, 780 hours. Sigma, which is population standard deviation, and 40 hours. CL stands for confidence level. At 0.95 probability, we have to find the confidence interval, and the corresponding z square is 1.96. Student, we we will use the following, this one, this interval, where a lower limit can be obtained by subtracting the error, the sampling error, from the estimated sample mean, and from the right side we add the error during sampling to the sample mean. For the upper limit of the interval, I'm again telling you this is the lower limit of the interval, and from the right side is the upper limit of the interval. Now students, we are going to substitute the values, the given values from the sample in this interval. 780 was the x bar value, and the corresponding 1.96 z score value. Sigma was the 40, and square root of n. The n stands for the number of observations, and which were 30. Same, same value, student, this same value for upper limit of the estimation, interval estimation, we add to the sample average, which was 780 that we have calculated earlier. After calculation, students, we will find the upper limit and the lower limit of the estimation. I'm going to find the calculator through which I will show how we will calculate this interval. We have got calculator. 780 minus the lower limit of the estimation. 780 minus 1.96 times 1.96 times 40 upon square root of 30, which will give us the lower limit of the estimated interval. Okay, where a square root of 30. Okay, something went wrong. I'm again 780 minus 1.96 times 1.96 times 40 divided by the square root. I was mistakenly not use the square root. Now I'm going to use square root, which is equal to 765.69. This is the lower limit of the estimated interval. I'm going to show the result. This is our result, students. See, 765.69. And for upper limit, I'm going to use calculator again. Now students, I have to just put the positive sign for the upper limit. Here we have to add the sampling error, then is equals to 794.331. Going to check the answer. I'm going to show the calculation of the first interval, then you will be able to calculate the values. Students, see, 794.31, which is the value of upper limit, and the lower limit was 365.69. We can also write in this interval notation as well. here like this. One can write also as writing I am 7 6.69 to some books I have seen. The above interval can also be written in this form: 765.69 to 794.39. What it tells us, the population mean may contain in this interval at 95% confidence level. It means we are sure 95% that the confidence level, that the interval or the value of mean lies in this interval. For this we are sure 95%. Okay, student, question example number 2. In example number 2, I am discussing case number 1b, when standard deviation of a population sigma is unknown. Student deviation is unknown, but the sample size is greater than or equal to 30. If the sample size is 30 or greater than 30, we use to find the same we use to find the interval by using the same technique, but a little difference. Student listed here, we are using S, the sample standard deviation, instead of population, because the population of the population is not given, but the sample size should be greater than or equal to 30. Okay, now students, I'm reading the example for you. A random sample of size 64, sample observations are 64, is taken from a normal population with unknown mean and variance. The sample mean is 120 x bar, and the standard deviation is 5 s. Set up a 95% confidence interval for the population mean. We have to set up a 90% confidence interval for the population mean. I've extracted the data. N is 64, x bar is 120, the standard deviation of population is 5, confidence level confidence level is 90%, and the corresponding z square value is 1.65. The same calculation, student, we have to do, but instead of sigma we use S. All the steps are same as we have done in previous example. See students, S, just S is different in this example, which is 5 which is 5, and after calculation we will obtain, and I have obtained this interval. The other notations are the same that we have used in the previous example. Interpreting the result, the population mean may contain in this interval at 90% confidence level. Now, students, I am giving a reading, or we are going to study example number 3, where uh, the case is different from 1A, 1B. That is why I have written case 2. In a random sample of 15 measurements, now students, we have see the the observations are 15, and one thing also, which is illustrated later. I'm reading again. In a sample, in a sample of 15 measurements of the breaking strength of cotton thread, the mean breaking strength was found to be 7 ounces. Student, this is X bar, and the standard deviation was 1.5 ounces. This is sample standard deviation, which is 1.5 ounces. Obtain 90% confidence interval for the true mean breaking strength of the cotton thread of this type, assuming the breaking strength to be approximately normally distributed. Students, we haven't given the standard deviation related to population, or population standard deviation is unknown. And also, one thing is the sample observations are less than 30. Here we have written in note for you. Note, In this example, observations are 15, which are less than 30. For this, we use student t distribution, which is approximately normally distributed, to find the confidence interval for the population mean. Students, I will make a separate video to find in which I will explain how to find the corresponding t score value, which is 1.6 with 1.761, and the other attributes from this example I have written here. N is equals to 15, which was the sample observations. X bar is the sample mean, which is 7 ounces. Standard deviation is the standard deviation, which is 1.5. Degree of freedom in students, because it is a student t distribution where the parameter of the t distribution is degree of freedom, which is simply n minus 1, means 15 minus 1. It is related to find the value of the t score from the t distribution table. I will make a separate video to estimate to explain you how you will find the t score value from the given degree of freedom. Okay, student, in this example, as as we are using the t distribution, therefore the z score is eliminated or displaced by t score t alpha by 2. Instead, we use t score. And student, there is s, because standard deviation of the population is not given, so therefore we use s, and sample is approximately normally distributed. Student, all calculation are same. For lower limit, we subtract the sampling error from the pointed estimated value, and from the same in the right side, where we add the sampling error into the x bar, or point estimated value of the mean, population mean. Now, after substituting the value, students, the same calculation as we have done in uh, example 1, we obtain the interval estimation related to our problem at 90% confidence level, or we can write in another format. I'm interpreting the result. The population mean may contain in this interval at 90% confidence. Students, we are 90% confidence that the estimated, or the average, or the mean of the population must contain, or likely to contain, in this interval, we are sure 90%. Okay, students, with the following examples, the following tables shows how confidence level and the sample sizes affect the confidence interval. Students, the following examples, the following tables I have taken from the book Applied Business Statistics, third edition, by Trevor Wagner. In this example, students, effect number 1, we are going to discuss, which is illustrated in this table. Effect number 1, influence of confidence levels on confidence interval width. In this example, students, see in first column, there are various or three types of confidence level, or one can say the confidence level is increasing. Here is 90%, 95%, and 99%. And the corresponding confidence interval is here 76 to around 80. And we can say the difference, we can calculate the difference, 76 to 80, which is 5, and 75 to 80, which is almost 6, we could, or 5, 74 to 80, 81, or we can find the difference, and we can say, students, from the 90, 95, and 99, the confidence interval is increasing or getting wider. Here it is illustrated or written: as the confidence level increases, the interval becomes wider and hence less precise. This shows that there is a trade-off between precision and confidence. Okay, student, effect number two, influence of the sample size on confidence interval precision. In this example, sigma is 21 and z score is 1.96, which is fixed from sample to sample. Student, in first sample, we have the sample size is 50 and 300 and 500, in which the corresponding intervals are calculated in this third column. And here is written as the sample size increases, the standard error becomes smaller, resulting a narrower confidence interval. This leads to a more precise estimate of the population parameter. Conversely, smaller the sample sizes result in larger standard errors. Smaller the sample sizes result in larger sample errors, and consequently wider the confidence interval, therefore less precise the confidence intervals. Okay, students, from these effects we have discussed, and we have also discussed the two cases, and it's enough for this video. I will, inshallah ta'ala, bring the new video where we can discuss how to calculate the corresponding Z score or T score value from the tables. Till then, Assalamu alaikum, Allah Hafiz.